Let's begin by understanding what Newton's laws of motion are. These laws were proposed by Sir Isaac Newton in 1687 in his famous book Philosophiae Naturalis Principia Mathematica. They form the foundation of classical mechanics, explaining the relationship between force, mass, and motion. So, why do we still use these laws today? It is to explain natural motion, like why objects fall, roll, or stay still. Second, to design machines and vehicles, engineers rely on these laws to build cars, planes, and rockets safely, and thus to solve physics problems using formulas like F equals to ma.
Now, to understand more about Newton's three laws, we need to see what is each of the three laws that Newton has invented. For the first law, it is law of inertia. An object will remain at rest or in uniform motion in a straight line unless acted upon by an external force. To elaborate it, objects don't change their motion unless something forces them to. If something is still, it stays still. If it's moving, it keeps moving at the same speed and direction, unless a force like a friction or a push changes that. For example, a book on a table stays at rest until you push it. For the second law, it is law of force and acceleration. The acceleration of an object depends on the net force acting on it and its mass. To put it in a simple words, force equals to mass times acceleration. For elaboration, the more force you apply, the faster something moves. Heavy objects require more force to move or stop. For a real life example, it's easier to push an empty shopping cart than a full one. And now the third law, action and reaction. For every action, there is an equal and opposite reaction. For the explanation, when one object exerts a force on another, the second object exert a force back that is equal in size but opposite in direction. For example, when you jump off a boat, the boat moves backward.
So now let's move on to the problem statement and its solution. So for the first question, this question involves Newton's first law. So the question is, a box of mass 35 kg is placed on a rough horizontal plane. The box is pulled by a force which applied at an angle 35 degrees above horizontal. If the coefficient of friction is 0.2 and the box moves at a constant speed, calculate A, applied force, B, normal reaction, and C, friction force. So first of all, let's draw the free body diagram. As you can see above me, there's a free body diagram that I already draw. So to solve A, we have to find vertical and horizontal force. So after we find both of these forces, we do the simultaneous equation, and we got F equals to 73.53 Newton. And so now B, normal reaction. We have to find what is R. So based on question A, we can find R, which is 301.1749 Newton. And C, friction force. We are given the coefficient of friction equals to 0.2. And based on B, we already got R. So 0.2 times R, which is 301.1749, we get 60.23 Newton.
Hello everyone. For question 2, I will be explaining this question and solve it together. For this question, we will need to apply Newton's second law, which is force equals to mass and mass times acceleration. For this question, the body of mass 5 kg subject to forces 8I minus 4j Newton and negative 5I plus 2j Newton. Find the acceleration produced by the body in vector form and state the magnitude and direction of acceleration. So, in order to find the acceleration, we will need to find the resultant force. Since there are two forces that are acted upon the object, we will combine those two. 8I minus 4j minus 5I plus 2j we will get our forces, our net force, which is 3I minus 2J. And then we will substitute both the net force and the mass into the Newton's second law. And then we rearrange the formula so that we can get our value of acceleration, which is 3 over 5I minus 2 over 5J meter per second square. And now, to find the magnitude, all we need is to substitute our I and J into the formula, and it will be square root 3 over 5 square plus negative 2 over 5 square. The answer is 0.7211 meter per second square. And now for the direction, to find the direction, we will need to use tangent inverse. And then we substitute our J and I's. It will be tangent inverse negative 2 over 5 over 3 over 5. We will get negative 33.69. But we need in a positive angle, so we minus it with 360 degrees. 360 degrees minus 33.69 will be 326.31 degrees, and that is the direction of the acceleration.
Now I will explain the question for the Newton's third law. The question is, two blocks of mass 5 kg and 7 kg are in contact of a frictionless horizontal surface. A constant horizontal force of 20 Newton is applied to the 7 kg block pushing the system. So the question is, find the acceleration of the system and the contact force between the two blocks. For the question A, we will use the F equal to ma formula, and we will get 20 minus F contact equal to 7a for the 7 kg box. Then we using the same formula to the 5 kg box, and we will get F contact equal to 5a. So we substitute the second equation to the first question, and we will get a equal to 1.667 meter per second square. So for the question B, we will use the formula F contact equal to ma. The m is 5 and the a is 1.6667, and we will get 8.3335 Newton. For conclusion, Newton's 3 law of motion form the foundation of classical mechanics and help us understand how objects move in our everyday world. The first law explains that an object remains at rest or in uniform motion unless acted by a force. The second law shows how the force applied to an object effect its acceleration, highlighting a relationship between force, mass, and acceleration. The third law reminds us that for every action there is an equal and opposite reaction. Together, this law describes the motion of objects and the force that influence them, playing a crucial role in science, engineering, and technology.